Hi, welcome to everyone's favourite segment, Mailbag. Let's start out with the biggest one because, well, I need to clear the shelf. So let's get to it. This one comes from Antony, I think it is, Berkovici. Sorry. From France. Hi to all my French viewers. There's a note on here. Please read the note inside first. Okay, no worries. Let's crack it open and see what we've got. Obviously, we have instructions. It's important we read the note. You might hear some construction noise. So they're moving into... Someone's moving into the office next door and they completely gutted the place. So here we go. And it's right on top. Thank you very much. Dear Dave, electronics hobbyist since I disassembled TV at the age of 6. Who didn't? I can remember when I tried to fix our TV, I forgot. I knew about Live Shazzy's TVs, but I just forgot in my excitement of tearing, the TV apart and trying to fix the coax cable on the back. Was actually the shield of the coax cable going to the antenna connector was actually at mains potential. So crazy, all they had was just the isolation cap there. Everything inside, Live Shazzy TVs, dangerous. Do they have Live Shazzy TVs anymore? Don't think so. Anyway, Trap for Young Players, those ones back in the day. Okay, I've read the note, but I think I'll just show you what's in the box rather than take it out. It's very delicate, and I've done a video on these before, but always great to have these. They're from, a bit of a spoiler, from Dallas Semiconductor. So, who were, back in the day, Dallas Semiconductor were the duck's guts. I used to love Dallas Semiconductor parts. Anyway, so I think we're going to like what's in here, but they're very delicate. So, I won't take them apart right here. I'll just do it properly and then set up the shot. Here we go. So Antone's teamed up with his Finnish friend Paulie, and they document silicon dyes. So they micro-photograph these things, and they're making them all available on Wikimedia Commons. That is just awesome. Check it out. I'll link it in down below. So they've got a lot of... what they've included, yes, they're very sharp, by the way. I'll link in a video to Vincent Himpy has sent in some silicon wafers and stuff and various other stuff, silicon manufacturing stuff before, so I have to link that in. But these are some Dallas Semiconductor designs and things like that. So awesome. Thank you very much, Antwin. Sorry, I don't know how to pronounce your name, but this is fantastic. And these are some of the wafers it looks like we got here. The old Dallas Semiconductor ones, the old one-wire ones. Look at this, the one-wire ring. I love it. The old I button and things like that. Micro power dual op amp. Look at these fantastic photos. I'm sure they're available in full HD. Oh, geez, there's tons of them. Look. Oh, beautiful. I'd love to be able to micro-photograph these, but it's an art, actually, micro-photographing dyes. You can't just buy a, $100 USB microscope and expect to get fantastic photos of dyes and things like that. So we've got some miscellaneous 5-inch wafers from AT&T and Bell Labs. Open this side up. Whoa, hopefully they're intact. Look at this, different manufacturing steps. Oh, unpolished. There you go. There's the unpolished wafer. Fantastic. These are incredibly sharp. So I probably should be wearing maybe gloves before I handle these. But anyway, let's give it a go. Back polish tested. Woo! This is fantastic. Sorry, this is probably not the best light for this. Hang on. We've got another one. Got other steps. Here we go. Blue tape. They put blue tape on it. Why do they put blue tape? There you go. And then diced. That's when they slice them up. So this one is going to be all floppy. Yeah, it's all floppy doppy because they really have chopped this one up. That's just, look at that. Look at the shimmering. Look at the shimmering you can see on that. That's because they got out the diamond saw. Wow. Oh, beautiful. Oh my goodness, there is so much goodness in here. I'll tell you what, I can't possibly show them all in the mailbag. This is only one part of one box. Oh, this is fantastic. I am going to have to get my Olympus microscope up and running. I've actually got some footage of me unboxing it, and it was like broken when I unboxed it. Needs a light source and stuff, so I've actually got to put a bit of work into it. I might just upload that unboxing video onto my second EEVblog channel too, so link it. Hopefully I've got the footage somewhere. It was a while ago, and I have to get a microscope, camera mount and everything for it, but oh, that's just, it's beautiful. Oh, I just can't stop playing with that. Oh, check out this wafer holder. Oh, you can see the Dallas semiconductor goodness in there. Look at this. This is all totally custom, designed to transport these. You can see the little rubber things holding the, wow, holding the wafers in there. Wow. This is going to provide, endless opportunities once I get a decent microscope up and running. Oh, thank you very much. This is just awesome. Wow. Anyway, too much goodness for the mailbag. Ooh. I'll get what I can using a simple microscope. But we're seriously not finished yet. This is a wafer bonanza. KLA Tencor 8-inch. Ooh, top wafer is split. Tencor? Uh-oh. I think there's been some shattering. I think I just got spiked. I may have just got spiked. Damn it. Okay, I'm going to have to be careful. Here we go, these KLA Tencor ones, they specialise in yield and reliability test equipment for the semiconductor industry. Has included several temperature recording wafers in various manufacturing stages, some of which are featured in this YouTube video. I'll have to link it in. Awesome. Anyway, he's also got some available on eBay. Link in the eBay store as well if you're interested in buying some wafers from Antone. Thank you very much, mate. This is awesome. Wow. Look at that. That is incredible. Can I spin the whole thing around? Wow. Look at that. We've got a temperature sensing board on there, presumably plasma temp. Wow. And the rest of it, I don't know how they're sensing the temperature or why. Sensing the temperature across the 12-inch wafer? I didn't know that was a thing that was done. Anyway, if anyone's got any really technical details on how and why they do the temperature sensing of these 12-inch wafers, then love to hear about it. But look at that. Wow. Oh, I'm taking this 8-inch pizza back. It's cold. Next up, one from Australia. I do all my Aussie viewers. From person oh no, hang on. No, here we go, from Paradox Photography. Thank you very much. Lewis, is it? Let's have a look. Ta-da! Let's check it out. Okay, this could be a bit tricky. I should use the Stanley knife, but, you know, what's the fun in that? Get the tongue at the right angle, and here we go. It's all rattly. No, it is not a Seagate hard drive or whatever. I'm pretty sure it's not. If it is, it's not in good shape. We've got, crusty lead light bulbs, and whole bunch of miscellaneous stuff. Let's take a look. And Lewis has sent in a bunch of stuff. He found this at a local ham festival in Dural. Didn't know there was one. This is an analog meter. He got this in a junk bin. He got like a whole box worth of stuff for $20 at a ham fest. You can get that sort of stuff. So yeah, there you go. Oh, by the way, there he is. There's Lewis. This is a some sort of running joke he had with his mate. Hey, it's even face tracking. There you go. My camera is face tracking. Or it doesn't know which has chosen this face now. I was choosing this one before. Oh, there we go. Now it's not focusing on there. There you go. Good on you, Lewis. And this thing, look, check it out. It's a 20k ohms per volt. Oh, yeah, rocking. And it can do 1 milliamp up to 10 amps. And, well, just select volts if you want. And then there would have been an additional dial for the volts one as well. But that's, there you go. Look, wire wound resistors. Love it. Well, current shunt resistors, that is. And a 10-turn trimmer. Look at that. That'd be the 10 amp jack right there. Oh, wow, that is crusty burger. Look at that. Spring-loaded mechanism. Feels all right. Bit crusty for its age, but yeah. And you also sent in this LifeX bulb, or LifeX, or however you want to call it. I actually, it's broken apparently. I actually saw an early prototype of this at the Melbourne Hackerspace, because Andy Gelm, he is one of the, potted, Andy, what have you done? No. Jeez, oh, that's no good. Anyway, it looks like all the high voltage conversion is done in there. There you go, 1000 lumens, blah, blah, blah. 17 watts, blah, blah, blah. 22 watts, blah, blah, blah. Anyway, very disappointed. That's all gunked. It's not a hard resin. It's one of those rubbery type ones. So, meh. But still, yeah, we're not going to get that open in a hurry. But there you go. There's the rest of the guts. That's the... there's the antenna. There it is. What is it? A Bluetoothy? No, it's a Wi-Fi. It's wireless, isn't it? So, yep. So, no big deal. But, yeah. There you go. LifeX. Yes, this was one of the biggest crowdfunding campaigns at the time. And they eventually delivered it. I haven't read up on... the performance and, you know, whether or not all the backers and stuff were happy. But, you know, a lot of issues goes into the thermal design of this thing. And this is all heavy die-cast alloy, of course, to dissipate the heat. Aluminium-backed PCB down in there, of course. And can we see some, see some thermal paste up under there, trying to get it through to this finned design, because it's all passive cooling. And the problem with these is that you stick them inside a sealed enclosure, lighting fixture, and they just heat up and heat up and heat up because there's nowhere for the heat to go. You know, you can have as much metal, as many fins as you want. Fins don't do much if you haven't got air flowing over them. So, yeah, it's, you know, designing proper thermal design for lights is a real big-ass issue. But there you go. It's a side look inside the LifeX. I'm not sure whether or not that's early production or late production or whatever, but... there it is. It's got to be some sort of arm thingamabob. Have they got a barcode on that? Hey, they've got their own label. There you go. They ordered enough of them. They got their own branding on. You know, you can do that with any manufacturer, of course, of silicon. They'll happily laser etch and give it a new part number. Anything you like if you order enough of them. So, here you go. Not sure that's, you know, some flavour of ARM processor or something, I'm sure. But there you go. It's interesting to note, though, that they couldn't fit the circuitry, or maybe they didn't want to because of the antenna, things like that. They didn't want to put it inside here. Anyway, this is all the, that'd be your mains, of course, and all your LED PWM switching as well. And you can see that connected down in there. They just use these long pins. It all mates up like that, goes in. It's quite a nice, elegant design. I rather like it. So yeah, I hope it worked out for him. But yeah, as I've mentioned on the amp hour over and over again, I am not a fan of internet or, you know, anything connected light bulbs. It's just, for niche applications, fine. Otherwise, just give me a switch on the wall, please. And I'll link in Lewis's blog down below. Check it out. Thanks, Lewis. Next up, one from the United States of America. Thank you very much, Sebastian. No last name. That's not his last name. It's just no last name. From Washington, D.C. Let's have a look. It's got one of these pull tabs. It works. Got to use the pull tab because this is one of these ones full of all that crap. Oh, and we've got a... oh, yeah, yep. Silly me, I just got over vigorous and ripped it, and sure enough, all the crap comes out. Ah, bloody hell. And inside we have a box. How do you open it? Hello, McFly. Oh, here we go. Is this one of the? Is this a rip pull one as well? Oh, I don't know. Here we go. Yep. No wuckers. All right. Let's see what's. Let's have a look. Got a whole bunch of photos and stuff, but danger! Whoa! A photon counting module. Awesome! And we've got a CCD camera as well. Cool, let's check them out. And there's Sebastian. I don't understand what that white stuff is. Don't get it. Oh, I tell you what, it's not every day we get one of these puppies. Thank you very much, Sebastian. This is a photon counting module. I love how it says module computer dephotons. Anyway, made in Canada. Hi to all my Canadian viewers and probably a French-speaking part of Canada because some parts are weird like that. Anyway, from Perkin Elmer, who make lots of funky, very scientific instruments and things like that. I've done some Perkin Elmer stuff on the blog before, I'm sure. But this is a very expensive kit. It goes for about $5K US. Sebastian was kind enough to send in this one, which is apparently still working, but it's got high dark count on it. So yeah, it's probably just, just slightly failing the spec for the dark counts. And this one is completely failed. So we can do a 2-minute teardown of this puppy. So these things are pretty schmick, apparently. There's the sensor inside this thing. It's over the visible light range. It uses a unique silicon avalanche photodiode circular active area that achieves a peak photon detection efficiency of more than 65%. The photodiode is both thermoelectrically cooled. I guess that means Peltier device on the bottom of it. Can we actually, would there be a Peltier thing at the bottom that actually keeps the thing cool, perhaps? Ensuring stabilized despite ambient temperature changes. There you go. So you got to keep the thing as cool as possible. This is detecting individual photons. So yeah, pretty advanced stuff. Typical applications: LiDAR, photon correlation spectroscopy. Thank you very much. Astronomical observations, optical rangefinder adapting, ultra-sensitive fluorescence, particle sizing, all the good stuff. All the particle sizing in terms of, scientific instrumentation, analysis, materials analysis, and, chemical analysis, all that sort of jazz. The formula for those playing along at home. Oh, we've got a block diagram. Look at this. Active squelch, active reset circuit, stabilized high voltage power supply for the puppy, and detector temperature controller. Doesn't show much else, but yeah, that's all the magic, and TTL out and the gating input as well. I have no idea what that is, but it looks impressive. A typical PD scan, obviously. And it looks like we've actually got a calibration sheet for this one. We've got our serial number 8114, and there we go. It measured 230 on the dark count, 250. So that's not over. So I don't know why it's got written, high dark count on it. So maybe it has, it's failed just a little bit since then. But yeah, there you go. 2nd of March, 2002. Good on you, DD. We've even got ourselves a linearity graph with the correction factors and the rate count. Awesome. So Sebastian's actually a senior engineer on a LiDAR project, and I need to show you this. Look at this. Look at that. Yes, that's a big freaking laser shooting up in the sky. It's like the Death Star. And he's warning, be very careful not to let too much into the light into the fiber port, because they're designed to detect single photons, tens or maybe hundreds of photons or something like that. So yeah, we, really need to watch out with this puppy. It's very curious that you can actually damage the thing, so that's very interesting. There's no, warning, there's high voltage warning on the thing, but there's no warning about, excessive light, maybe when it's powered up, perhaps. But anyway, let's see. And I think they killed the other one with 12 volts instead of 5 volts for the power supply. Our familiar equation, E equals HV, even room lights generate microwatts of power, will exceed this 13 megahertz by a wee bit for the detector. This is real science shit. Awesome. So they use these detectors in aerosol LiDAR to collect data about the vertical structure of the atmosphere. I am sure I don't need to explain this to you. Well, yeah, I think you do, Sebastian, because I don't know much about atmospheric LiDAR measurements. We transmit pulse laser light in the atmosphere and count how many photons are recorded from the backscattered light at the different ranges. This gives us a data product shown below, which shows the layer in the sky from various aerosols. Very cool. In this particular example, the layering later in the day is smoke from forest fires from our Canadian neighbour during summer, and the systems are pulsed at 2.5 kilohertz average and average over 1 minute, so 150,000 pulses create a 1 minute profile. We also modulate the outgoing polarization of the system, so we're able to collect two signals using the same detector and look at how different aerosols backscatter different polarization states. Absolutely fascinating. Love it. Alright, so let's just quickly power this thing up. I've still got the black protective cap on there. Single 5-volt supply, no gating signal. And we'll see what we get out. And you can actually see the pulses here. So there we go. I've actually had to set the memory depth, quite high here. I mean, if you set it to 14K, you just can't get, it just disappears. It doesn't have the memory depth to show them. And you'll see, if you increase your memory depth, then the spikes just appear as shorter than what you would normally expect. 1.4 meg. Now we're talking. Anyway, we can start to zoom in, and that's what we get. This is 5 volts. Where are we? 5 volts per division, which is rather interesting. So that's our output pulse. So it has a it actually goes positive and negative. I'm quite surprised at that. Anyway, if we go to like 5 milliseconds per division, and let's just increase our memory depth there right up to 140. Whoa, thank you very much for playing. And we can see the multiple counts on here. If I put my hand over it, does it get any less? I don't know. I'm going to go switch off the lab lights. Hang on. Hasn't really significantly lowered, has it? So I'm not sure what the deal is. Anyway, is that just our normal dark count, perhaps? Anyway, Sebastian's got a question about the LiDAR application. Is so intense, the laser, that it actually saturates the detector and causes a very long tail of pulses. And you can see the long tail out there. So he's just wondering, because it corrupts the first 2 microseconds of data. He's asking if I have any theories as to why this happens after inspecting the unit. I don't know. I'm sorry, Sebastian. This is not my area of expertise, but maybe somebody else, one of the viewers out there, might actually have an idea what's actually at play here. Okay, so I've got all my lights off, but of course, I've got light filtering in from the corridor here and the screen, of course. So, but I'm going to take this. I'm going to take this cap off. Hang on, if I can get it. Let's have a look what happens. I expect it to saturate. Oh yeah. Hello. Whoa! I've put my thumb over the end of it. My thumb is over the end of the connector. Look at that. Wow. Look at all those pulses. The number of photons. Tons of them. So yeah, I don't want to damage the sensor, but jeez. Yeah, I mean, that's my thumb. Trust me, is over the end of that fiber optic connector. So it's obviously getting through my thumb. You can shine a torch to your thumb, put a torch up to your thumb, and you can see the light coming through. But yeah, that's not enough. I've got to put that's taking my thumb off. Wow. And this is putting the dark cap on. Here we go. Wow. Woohoo! And cap on. Beautiful. And we're back to our, pulse every 500 microseconds or every couple of milliseconds. Now, you may not be able to see this, but I've got the fiber optic here, and if I point up towards the screen, I've plugged it in, point up towards the screen, you can really see that thing going ballistic. Wow. That's terrific. Whoop, whoa, I killed it. But it's recovered. Oh, yeah, probably don't want to do that too often. Yeah, really sensitive, but... Oh, poor photon counter. Can't keep up. All right, let's pop the hood on this puppy and see what we've got. Oh, it's pretty average looking, isn't it? We've just got a regular PCB in there with a couple of jelly bean looking SO packages, and we've got an off-the-shelf switch mode. I think that's one of those TI. Is that one of those TI jobs? One of those switch mode power supplies? I'm not sure. TI got into those. Looks quite similar, but yeah, could be from anyone. Anyway, that's not surprising because when you get if this is worth 5,000 US bucks, right? And they don't make these in high volume, it's serial number like 8,000, and you just don't bother rolling your own DC to DC converter. The designers just couldn't be bothered. They just go, nah, cost really isn't a problem. We'll just whack in an off-the-shelf DC to DC converter module that costs 50 bucks. Yeah, no one cares. There you go. It looks like we've got is that a transformer? Got some isolation there for our output. You'd expect that. But not a huge amount more. All the magic, of course, happens down in the sensor. That's what you're paying for. That puppy there. I wonder who manufactures it. Is it Perkin-Elmer? Or, I don't know, do they get it from somebody else? But, yeah, let's take the cap off. We can destroy this one. No wuckers. And if you're wondering if I can get that off, no, you unscrew it. That's just a socket, and they've got some thermal paste in there. You can see that just using the case as a heatsink, of course, and they got some fins on here, but everything's sealed inside that module. But we can actually, they showed the photo of it on the data sheet there, so that'll do us for now. Let's go through a couple of cheap and cheerful Chinese eBay items, shall we? I'm sure they are. This one's like torn apart, so as always, I don't know who these come from. Really, I think people have just ordered them and had them directly shipped. Oh, what on earth is that? It's a wet baby alert. Oh, goodness. Come on. Oh, goodness. Oh. Okay, next. Got another one. What is it? Dig item. Might come in handy, but I think it's probably going to be a bit crusty. Probably costs, $5 delivered or less. Oh. Don't even want to touch it. But I have to. Oh my God, that's the worst mains cable I've ever felt in my life. Oh, there's no cord strain relief at the end of it. One of these mains powered soldering irons. Are you kidding me? There's no 40 watt, 240 volts with an American plug? Huh. Wow, I wouldn't dare plug that in. Are you kidding me? Ugh. It's going downhill. It's going downhill, folks. Let me tell you. Once again, I have no idea. They all come in the same. You can just tell, like the label printed from the. Oh yeah, one of these bloody LED light Foxanonymous. Yeah, light bulbs. They're just crap. Don't buy them. They're garbage. No. Just no. No. This thing looks like it's 3D printed or something, this handle. It is... Just... No! This is the... No! No, that's not an optical illusion. It's just not even worth describing. Look. Unbelievable. How can this crap even be legal to sell? Wet Baby Alert adopts quality Integ-rated chips and imported components that give a high sensitivity to the product. It totally gets rid of your worry that the baby catches a cold due to bedwetting or suffers from crotch eczema. Schematic diagram of Wet Baby Alert. State-of-the-art technology, and no need to trim the component legs. Pfft, bugger that. Photon. Yeah. Not for use in enclosed light fixture. Not for use in enclosed light fixture, in case you didn't get it the first time. Oh yeah, this thing's gonna work a treat with its HY brand 400 volt cap. Look at that. Oh, goodness, I probably give that a week before the board starts charring or it catches on fire. China QR. Yep, that instills a lot of confidence in me. Next up, one from Alexander Ruse from Germany. Thank you very much, Alexander. Hi to all my German viewers. Let's check it out. It's very thin and light, so I don't know what it will be. It's an envelope with a note. There's a tiny little module in there. We've got ourselves a little module. We like having a look at little modules. Let's check it out. So Alexander founded his own company in 2005. Geez, that's now 11 years ago. Scary. He only had one product he ever developed. He's not going to tell us what it is, but you can look at the following things. Tiny little board like this, and we've got this thing with it. So he's talking about connect up hall sensors and LEDs and all sorts of things. And for those who read German, there you go. There's the functional description of the thing and how to hook it up and everything else. It can hook up a motor and magnetic field sensor and all sorts of jazz. But I've translated that and with Google Translate, and here we go. It's been developed specifically for use in car vehicle systems, operates from a voltage of 1 volt. That's very cool. And so interesting for vehicles with one battery, obviously little model vehicles. The board operates as a brain in the vehicle. You can get a magnetic field sensor and LEDs connected up. Small magnets under the road service module start in position of emergency operations. So it's basically designed for like little model cars on like model railways and things like that, like the miniature wonderland, which I have been to in Hamburg, by the way, the world's biggest. Oh, geez, it's awesome. It's even more awesome now since when I went like 10 years ago, but yeah, it's even more awesome now. So it's designed for something like that, automates like little, cars running around on model layouts, presumably, and stuff like that. Please correct me if I'm wrong, but that seems to be what it does. So, very cool, Alexander. How did the, leave it in the comments. I presume you didn't go or didn't sell all that well, because, sounds like you're not in business anymore. Anyway, thank you very much, Alexander. Very interesting. And this is one instance where you really want to miniaturize this thing, so the tiniest components you can get possible just to fit on the tiniest board. Yeah, hand soldering this isn't really a hugely viable option, so you got to, get it properly refoed. But yeah, tiny little packages like that, and you can cram everything in. Neat. Next up, we have another one for the United States of America from Plymouth in Minnesota, MN, I think it is, from the Dig WDF store. Thank you very much. And it is something we always like here. Ta-da! Merch. Awesome. Black, my favourite colour. Wearing my Spartan t-shirt today. I did the Spartan race yesterday. This is the one from last time though. Oh, look at that. Oh, right. Yes, do-it-yourself christmaslights.org. Yes, we've seen those. I've linked to that site on the blog before, I'm sure. Thank you very much, Dave. Good on you, Dave. So I'll link in Dave's do-it-yourself-christmas.org website down below, or I just told you what the thing is. Yes, DIYchristmas.org. Check it out. Thank you very much. Oh, it's got a collar. It's a bit fancy-pantsy for the EEVblog, considering that, I'm just rocking around in bare feet. Oops, I missed an eBay special. Let's check it out. It's going to be so bad. Oh, goodness. It's the amazing electric shocking pen. Oh. Well, this looks pretty pathetic. Anyway, it looks like what it's designed to do is, of course, you hold the pen and, you know, you give it to someone, hey, use my pen, and, well, you press that, and I'm sure there's a metal contact on the top, there's a metal contact here. I'm sure I'm about to get zapped. So, here we go. I'll take one for the team. Yeah, you can feel it. So let's just measure this. I've got my high voltage differential probe here, and I'll just touch this on here. So let's give it a burl, and we'll be able to see. I'll show you close up on the scope in a second, but bingo, there's the pulses. So let's take a closer look at that. There we go. You can see the frequency down the bottom there, about 80 hertz or thereabouts repetition, and we can single shot capture that. There we go, I captured that. So if we zoom in, bingo, we can see these pulses there, what, 20 microseconds or something like that. At, where I'm at 100 volts, there we go, 1 to 100 ratio. We're at 1 volt per division, so that's 100 volts per division there. So, 500 volt peaks or something like that for 20 microseconds. Meh, there's not much current behind it, so it's not going to kill you. And that's all it is. Couple of little hearing aid batteries or whatever they are, or 3 of them actually. Yep, and one little blob. There we go. One little blob with a big ass inductor, and yep, that's all she wrote. Next up, one from a fellow blogger whose channel is the very best of YouTube. Thank you very much, Owen Jeffries. He's from South Australia. Here in Australia, of course. Yes, it is down south. Go figure. South middle of Australia. If you want to know where South Australia is, or just Google map it. Let's see what Owen sent in. What is it? Good luck. It's got good luck written on it. Why do I... Looks like I'm going to need a lot of luck. It's one of... it's a stupid... Yeah, good luck opening the bloody thing. Alright, it's one of these, oh, it's an no, it's like an iPod clone thing. Is it? Yeah, I think it's one of those iPod clones. No, designed by Apple. Oh, no, it is Apple. It is actually Apple. Designed by Apple, but we're made in China. Where's the Apple logo and stuff? It's an Apple remote control for what? I don't know. Sorry, all you Apple fanboys, I don't know about Apple products. Okay, how do you even open that? Yeah. It's like one solid piece of aluminium. That is ridiculous. I'm going to have to dig out the buttons or something. Maybe there is an obvious way. Hang on. Yeah, this is totally fascinating design. It's like one big solid thing. They've obviously slid that in there somehow, but I'm not entirely sure how they get that in or out. There's our buttons. But yeah, how do they slide it all in? I'm presuming that it's a flex board and they just shove it in under there like that. It really is quite clever engineering case design, that. I rather like it. If anyone knows exactly how they actually manufacture that, it's brilliant. Let us know. And there's the battery holder plastic in there, hooked onto the board like that, and that's all she wrote. It's rather clever engineering. I'm impressed. Wow. Hi to all my Norwegian viewers. We've got one from DeLorean Jones. Let's set it to DeLorean Jones. Okay, thank you very much. K Venorum from... I won't even pronounce it. No, somewhere in Norway. Let's check out what's in here. I just read what it... Oh, please put me in another cache. Oh, right. It's a geocaching.com tracker. I want to travel around the world and other planets. There we go. It's a geocaching tag. Geez, I've been out of the game a long time. I used to be big in the geocaching scene. Used to even edit the Geocaching Australia newsletter. Go figure. That was a long time ago in a galaxy far, far away. Scala Rider Q3 with crusty dirt all over it. Okay. Anyway, I'm going to have to find it's a travel bug. That's the term I was looking for, travel bugs. I can remember when travel bugs were first introduced into geocaching. And yes, it's geocaching here in Australia, not geocaching, as you Yanks like to say. Don't come here and, you know, turn up at a geocaching event and go, I'm here for the geocaching event. They'll just point and laugh at you. So, the Viking farm. What? Oh, God, I can't even pronounce your name. Kettle, with a J in it. Thank you very much. And this is what made me laugh. Bullshit bingo. Yeah, I want to play bullshit bingo. So this is, oh, it's all in Norwegian, is it? I can see e-commerce. So the idea of bullshit bingo is that when you're in a meeting at work, you sit there with your bullshit bingo sheet. Here it is. There's your bullshit bingo sheet for those who read Norwegian. And you can, you know, sit there, and as soon as you hear a wank word, or it's sometimes called wank word bingo, or you hear one of the bullshit terms, you mark it off, and then if you mark all the words off in a meeting, you shout bingo, and then everyone cracks up laughing, and the managers don't know what's going on, but everyone's cracking themselves up. So awesome, Norwegian bullshit bingo, beauty. And there is the geocaching travel bug for those playing along at home. I will have to reactivate my geocaching account and actually put this in a cache, and then you can track it. I won't tell you which cache. I don't know. I'll whack it in something. Maybe I can put it in an old one of mine, perhaps, if it's still there. Geez, aren't I naughty? Haven't checked on it for many, many years. All right, yes, I know this is a geocoin. Geez, when I was a boy, travel bugs. I can remember when they first introduced them. They were, whoa! You'd go all over Sydney searching for a travel bug. Oh my gosh, somebody's got one. Oh, they put it in a cache. Quick, hurry, go find it. And now they got geocoins. I don't know. When I was a boy, I've always wanted my own coin. My own Dave coin. I think I'm going to mint my own silver coin with my face on it. Why the hell not? But hold on to your hats, folks. I just looked this one up, and this is the EEV coin. That's what it's called. So I'm going to throw this in a local cache, and any viewers out there who are geocachers, or if you're not, get into the sport. It's really fun. Highly recommend it. You know, it's just that I've got a life now. That's why I don't do it much anymore. I'm going to have to get more into it now that Sagan is at an age where we can take him geocaching, which would be awesome. So I'm going to whack this in a local cache and see how far this puppy can go. Excellent. So thanks to everyone who sent in something to today's mailbag. Sorry if I didn't get around to yours, but, you know, I do have a lot of them. I think I'm going to go geocaching. Catch you next time.
Hi, welcome to the EEVblog clean room. Or not so clean room. Why am I wearing a clean room bunny suit, you might ask? Good question. Well, we've got the ever popular mailbag segment. Very special one today. Inside this box is a whole bunch of semiconductor fab paraphernalia, courtesy of Vincent Himpy.